So for this first one, we have an example problem. It says that Laura and Becky are graphing and transforming the parent function cosine. Laura's function is a transformation where the parent function is horizontally compressed by a factor of 1/3 and is reflected over the x-axis. Becky's function is defined as f of x is equal to 3 cosine of x minus pi. Determine which graph belongs to each student. So I want to talk about transforming trig functions. So the first thing I'm going to do is I'm going to pull up the Desmos calculator. I like using the Desmos calculator for these things because it lets me show you in real time how the transformations occur. What I'm going to do, as soon as this thing loads, is I'm going to plug in y equals a sine of b, all this stuff, and we'll talk about how that works. So I'm going to say y equals a sine. So I'm going to add a slider for a. Sine. And then in here I'm going to say b. And then start parentheses. I need to add a slider for b though. X minus c. And then way out here, I'm going to put plus d. All right, add a slider for d. So right now, sine of x, I put 0 for c, and I put 0 for d. I'm just going to make these integer values because it'll be a lot easier for me. So 0 for C, 0 for D, 1 for B, and 1 for A. I get the regular parent function sine of x. Okay. Let's see what A does. So if I change A, if I increase A, that has an impact on the amplitude, right? So I can make it bigger or smaller. I can reverse it, but that changes the amplitude. It makes it bigger or smaller. Okay. Let's see what B changes. Oh, I want A to equal 1. All right. Let's see what B changes. Well, B either compresses it or you can stretch it too. But it compresses it or it stretches it. So C shifts it left to right. So this is very similar to what it normally, inside the parentheses, shifts it left or right. And then D shifts it up or down. So if D gets positive, it shifts it up, and D shifts it down. So C and D kind of still play the same role that they did with regards to translating. Okay. Back to our question. Well, the same thing for cosine. This is the same thing for cosine. So if I come in here and I type in cosine, it still does the same thing. So A will change the amplitude. D changes the shifting up or down. A needs to be 1. B compresses it or stretches it out, and then C shifts it left or right, or left or right. I'm saying the wrong thing, but you know what I mean. So now let's go back and look at what Laura and Becky are doing. So it says that Laura and Becky are graphing the transformation of the parent function. Well, A increases the amplitude. So Becky's function, this 3 times cosine of this, if I change that, I'm pretty sure it's this one right here. I'm pretty sure this is Becky's because the amplitude goes up to 3. All right. Now I can verify that by just coming in here. A is 3. B was 1. What was that? Minus pi. Ooh. C was pi, which is about 3. And then D was just 0. Well, the scale is a little different, but you could see that that looks like this function here. Okay. So this is Becky's function. So basically we have to label these. So this first function here, this is Becky. And there's only 2 people. So they want us to identify which graph belongs to each student. So one of these does not work. Well, it says when we horizontally compress something, what horizontally compresses something by a factor of 3? B does the compression, right? Compression by a factor of 3. I think if we change B to 3, oops, I did a little too much. I think if I change B to 3, A goes back to 1, because that's the only transformation. C is 0. C is 0. You get a function that kind of looks like this. So lower n, isn't that this one right here? Let's take a look real quick. Oh, and reflected over the x-axis. I forgot about that. So when it says reflected over the x-axis, that means that A is negative 1. Watch what happens when I do negative 1. Bam, there it is. That's Laura's function. So this is Laura. And this one is neither. Neither Becky's nor Laura's. Okay. Now this one was stretched out because basically this one is cosine that's just stretched out. Right? It has an amplitude of 1, but I think it was stretched out by a factor of... No, I think that's just plain old cosine, actually. Now that I think about it. Yeah, that's just plain old cosine. Anyways, that's the answers.